All right, folks, this is about my third attempt at this. Let's hope it goes. So today's lesson is the quadratic formula, using it to solve for one, two, or no real solutions. We're also going to be looking at the discriminant, which is a portion of the quadratic formula in here, but I'll show that after I've done the first four problems. Hopefully you'll recall quadratic formula from before. Most of the time it has been taught in integrated 1 or 2. For the standard trinomial, the number in front of x squared is a, the number in front of x is b, and the number without an x is c. This is the formula, and you must memorize it. There's a Pop Goes the Weasel song, which I don't remember. X is negative b plus or minus the square root of b squared minus 4ac all over 2a. And that is not the right tune, but you need to memorize it. So number 1, A is 4, B is 12, and C is 9. Simply the numbers in front at each position. Notice there are no x's involved. I'm going to take these numbers and put them into the quadratic formula. So x equals negative b plus or minus. Now, as you substitute, it's really important that you pay attention to all your signs and PEMDAS. Inside here, it's b squared minus, and I put a parenthesis around all three items because it's a cluster, 4 times a times c, all over 2a. So this is just the substitution piece, and if you don't do it carefully, then the rest of the problem gets, complicated. I now clean up things in sections, and my sections are here. I write this as separate things being subtracted, and you'll see what I mean at the bottom. So if you want to go quicker than me as far as your steps, I understand, but I'm trying to show the easiest way that we don't make mistakes. Whatever sign the b was, it changes. So for this one, we end up with a negative 12. Inside here, 12 squared is 144. And then the parentheses here, make sure you have your calculator handy. 4 times 4 times 9 is 144. All over 8. Okay, and then the next step down, you're cleaning up the square root. This one's a 0. Now, if it's a number other than 0, you might have to break it down. If it's negative, you might have to break it down and have an imaginary. We will always be cleaning these up. And this is a 0, which is kind of nice. It's going to make this problem a little easier. So x is negative 12 plus 0 over 8, or negative 12 minus 0 over 8. Here's the funny thing. When you end up with a 0 inside, you're just going to get really one answer, because when I do negative 12 plus 0, I still get negative 12. And I'm just going to reduce this down. So the solution is negative, dividing by 4, 3 halves. So negative 12 over 8 reduced is negative 3 halves. If I do this one, I get the same thing. So it's a duplicate answer. X equals negative 1.5 is the only solution to this problem. Okay. Number 2, please be careful, there's a 1 right there. So for this problem, A is 1, B is 3, C is negative 17. Substituting in, x equals negative b plus or minus the square root of b squared minus 4 times a times c. Be very careful, there's a negative on that c, and that's going to make a sign change in there. All over 2a. Okay, proceeding from there. Next step down. So change the sign of the b. In this case, it becomes a -3 plus or minus. 3 squared is 9. And then I have minus, and in the parentheses, I have 4 times 1 times -17. 4 times 1 times -17 is -68. And then on the bottom is a 2. That negative was in the formula, and there's a negative on the 68, so they will become positive. So I now have -3 plus or minus. 9 plus 68 is 77, all over 2. Always check, can I reduce or simplify 77? 7 times 11, those are primes. There's pairs in there, so it does not simplify. So my answer is right here. One of my answers, is -3 plus square root of 77, all divided by 2. And the other one's -3 minus square root of 77, all divided by 2. I'm going to be saving this paper because when I talk about the discriminant, we're going to look at all 4 of these again. Continuing on. Number 3. A is 5, B is 8, C is 11. Big numbers here. Substitute. X equals -b plus or minus the square root b squared minus 4 times a times c all over 2 times a. Make sure you see that what I got there. Next step down, clean up a little at a time. (64) minus, and this is 4 times 5 times 11. 4 times 5 times 11 is 220. All over 10. Continuing on, next step down. Do the inside math of the square root. 64 minus 220 is -156 all over 10. And now let me pause there. 4 times 5 times 11. Yeah, looks good. Okay. The square root of 156. I should say -56. Here we go. I'm going to have an imaginary. 156 is 2 times 78. 78 is 2 times 39. 39 is 3 times 13. Those are prime. So the 3 times 13 is going to go back inside, but there's a 2 that comes out. So when I rewrite this, -8 plus or minus, instead of that, it becomes 2i because of the negative. And inside, the 3 times 13 is there, and then 10. Now, for those of you that like cleaning up things, this can clean up one more time because all of these reduce by 2. If they didn't all reduce by 2, we couldn't do it, but they are all even. It doesn't matter what's in here, it's the coefficient numbers in front of everything. So the best way to write this problem is actually -4 plus or minus 1i, and you can leave the 1 off, root 39 over 5. So that's what we get after reducing everything by 2. We have one more example problem with the formula itself, and then we're going to analyze the discriminant and how it worked for these problems. let's see, going back to this wonderful little salmon color. Before we go any further, this is not set equal to 0, so I have to subtract 4x first. I get x squared minus 4x equals 0. Now this one is tricky. It only has an a and a b. It does not have a c. A is 1, b is -4, c is 0. This will make the problem a little simpler, like it'll be less work, but let's use the formula nonetheless. So, negative b plus or minus. Now be careful here, it's b squared and it's a -4, but it's going to be a positive in there, minus 4 times a times c, all over 2a. This is the first one I've shown you where the b is negative, so pay attention. There's going to be a difference here. All others ended up with a negative number. This one's going to be positive. This, even though it's -4, is still going to be a positive number when I get done squaring it, just like this one, just like this one, just like that one. When you square the b, the front number has to be positive. So x equals, these become positive 4 plus or minus square root of, hang on a minute, I thought we were plugged into a charging mechanism, but oh well. Let's hope my battery lasts. All right, so this is 16 minus 0, because all of this, 4 times 1 times 0 is 0, all over 2. This is a perfect square. So when I rewrite it, 4 plus or minus 4, that's the square root of 16, all over 2. And when this happens, always solve both problems. One of them is 4 plus 4 divided by 2. 8 divided by 2 is 4. The other solution is 4 minus 4 divided by 2. 0 over 2, or 0. So my answers are 4 and 0. Now the discriminant is just a piece inside of the quadratic formula. It's the b squared minus 4ac. And depending on what numbers you get inside of there, it tells you different solutions. These are the ones we all just did. I'm going to show you what the discriminant looks like and how, and then the answer so you can kind of see the combination. So if I just wanted the discriminant for this one, okay, just the b squared minus 4ac. Again, a, b, c, inserting it into this. So I put 12 squared minus 4 times 9, 4 times a times c. And I apologize if that seems too fast. This is a, b, c. And now if I work out this math, 12 squared is 144 minus 4 times 9 is 144. So this is 0, okay? The discriminant is 0. So look at these choices. Oh, 0. When you get 0 for the discriminant, you will get one real rational solution, which means one real number, a nice number, not a square root. This was number 1. That was our discriminant, and we got one nice, real, rational solution. Okay, now let's look at number 2. A is 1, B is 3, and C is -17. B squared minus 4 times A times C. 9 minus 4 times negative 17. I have that in here, but negative 68. We're going to add those. We get 77. Okay. The discriminant is 77. That's a number bigger than 0. Is this a perfect square number? Something times something? No. So we get 2 rational, meaning square root, solutions. That is what we got for this problem. 2 rationals, or known as square root solutions. Number 3. A is 5, B is 8, C is 11. B squared minus 4 times A times C. 64 minus, this is 20 times 11, which is 220. And I remember we got a negative number here. It was 156. If the discriminant is less than 0, negative, you'll get 2 imaginary complex solutions. This was number 3. Because this was negative here, we had to break it down and we got an imaginary complex solution. Last one. We had to move this over, and there wasn't a C. So A is 1, B is negative 4, C is 0. B squared minus 4 times A times C. 16 minus 0 is 16. This is a positive number. If you get a number that's positive, if it's a perfect square, you'll get 2 rational real solutions. So it won't be a square root, they'll be nice numbers. Here is 4. That was our discriminant. It worked out nicely, and we got 2 individual rational real numbers. So the discriminant is just part, it's the interior part of the square root. Depending on the kind of number you get, you'll get different types of answers. But I made sure I got 4 problems that had all the types. There is a class assignment for you to do. Thank you very much.